G'day, Adam, VK4GHZ, and with me is Doug, VK4OE. G'day, Doug.
G'day, Adam.
And what are we doing today?
Well, what are we doing here? It's Brisbane VHF Group's microwave tune-up and test day, and we've got a whole lot of test equipment set up that can test for many microwave bands, and people are going to be bringing along gear that they've made or got from all sorts of places, and be testing and trying it and see how best we can make it all work.
There seems to be a growing amount of enthusiasm and activity in microwaves at the moment.
Yeah, it's picking up quite well, and it's been a great buzz.
Yeah, it's great to see. All right, well, let's go inside and see what they're up to.
Okay, let's go.
G'day, I'm Kevin, VK4UH. Had a long-term interest in doing some microwave work, and I've assembled a series of transverters for various microwave bands extending from 2.4 gigs, 5.7 and 10 gigs, all in NEX medical cabinets. All the transverters I've built are based around the DB6NT transverter modules from Germany, and I've assembled them into cases with all the necessary power supplies for driving relays and sequencers and preamps and PAs, and the intention is that they all go out on block. They all work on 12 volts. They're all lockable with the same 10 meg GPS. They all work with an FT817. They all go on the same stand and interface up with the same dish. So I basically just take them out in a pack and swap one module for the another as we go from one band to the other. The 10 gig unit that I've have set up for you to see out on the trolley has a 2 watt output capability. The 5.7 gig unit has an ex-commercial PA which we've modified, and that makes about 12 watts on 5.7 gigs. And currently the 2.4 gig system is just running 2.5 watts with a possibility of building a bigger PA into the same case. The beauty of having a big box is that you can put bits and pieces in, modify things easily. If you ram it into a box that's too small and you want to change something, it's very difficult. So although they are a little bit cumbersome, they're quite useful, and all comes together. So here's the 10 gig transverter set up on what's basically an ex-theodolite tripod. It's a 600mm dish. I've got a various number of antennas which I can slot. They're all interchangeable, just interference fit into the dish so that I can change over. This particular one comes out on waveguide, so I've got waveguide clamps with the old-fashioned quick fit slip rings to transvert across. This is a GPS module. Came from England. It's commercially available, made by a ham over there. It just gives you a nice stable 10 meg reference. And the DB6NT modules have that facility. They have their own oscillators in them, and if you just run them up, they work pretty well. But if you want to have any more stability, you just plug them in, and as soon as it sees an external 10 meg signal, they switch over and use that. And it takes out, the one big variable of not knowing whether you're on the right frequency or not to the guys you're trying to talk to, and makes it possible to consider things like digital operating, and the various modes of the work are well below the noise floor, and aircraft scatter and all these other things where there's good potential for getting some range. They're all designed to run around an 817, beautiful little transceiver that it's handbag portable. Some of the transverters have 432 meg IFs, some of them have 434 meg IFs, some of them have 2 meter IFs. Doesn't matter, the 817 will cope with all those. And I've built into this some power outlets so that you're not fumbling with leads. Everything just plugs into the front panel, and it's very easy to use and set up for quick setup for when you go out portable.
What we're doing here is a return loss measurement and adjustment, looking into the 10 gigahertz input port of a dual band feed horn that Doug has made. And what we have is directional couplers, microwave directional couplers, which have been set up for a leveled input. This directional coupler is producing a leveled input from the signal from the sweeper, and this directional coupler here was set up for a leveled forward reading that gave a reference level on the power meter, and then it was turned around and it's now giving the return loss as seen by reflected power coming back into the meter. And if we're able to look at the little needle on here, if it was right up at the end here, it would be complete reflected power. And what is happening is that this is only showing 5 decibels of return loss at the moment, which is not very satisfactory. We've had adjustments with, for instance, this 10 gigahertz horn, and we're able to achieve more than 20 dB return loss by adjusting that little adjustment screw, which was found experimentally to be the right place for it, using a ball bearing and a magnet, by moving the ball bearing around on the inside and the magnet on the outside there. So that's quite a lot of fun when you get into microwaves.
As I mentioned earlier, on my 10 gig system I've arranged to come out in waveguide. Here's actually a transition inside the case. And these from just various bits and pieces. This is a penny feed that I assembled myself in the kitchen. Basically, didn't require any special tooling. And I've got a number of different feeds which are just an interference fit through the middle of a commercial dish of some nondescript origin. So here's another one, and they can just be interchanged, and they just slot in. It takes 5 seconds to change one feed for another. And I have another feed that I've made up for 5.7 gigs, which just fits into the same interference hole in the middle of the dish. So again, it's very easy. It's all mounted on just a piece of alloy plate. There's a hole that we milled inside which matches the thread on a theodolite tripod, so it just all goes together with a thumb nut underneath. And I used a pair of CDs as bearings underneath, just to allow the dish to spin freely for when you want to alter your heading, and to get it level, use a little tiny spirit level, and just alter the length of one of the legs to get roughly horizontal and pointing the direction you want. So all very easy and quick, assembled with little more than hand tools and a blow lamp.
Where's the schematic for that? So you should be able to wind the wiper down to ground one way and max the other if you just want to meter it.
That's right, so I want to, okay, so that's what we need to find out on there. One's transmit, one's receive. So
Yeah,
find
that's
out which
TX. This is the TX one.
Which one?
This one here that says TX gain.
Now we've got to find out. We've got to turn that right down so that there's no power out from there.
Oh, g'day, I'm Peter at VK4EA, and just show you some of my test gear I brought down for the test and tune-up day. So here we've got a Swoop oscillator. It's an old HP device, but very stable. Got plugins from 1.8 to 18 gigs. I use that for measuring return loss on antennas, feed horns, and that sort of thing. Pretty useful for that. An old spectrum analyzer I picked up quite cheap in the surplus market. A signal generator, which I use with the cone generator, which produces harmonics right up the spectrum, so it's very useful as a signal source. My frequency counter, which is good for 26 gigs. Again, not very expensive, got that in the surplus market. Very useful device. And my portable signal generator, which is not finished yet. I just ordered Adam VK4GH heads design for that. It's based on the Graham Burns XTK design. And at the moment it's putting out a harmonic on 5.7 gigs, so you can see it's a relatively clean signal, not bad for a harmonic. And this instrument is pretty old, and I've been trying to baby it so I can keep some years into it, because it's pretty expensive to replace. So starting from the left, just a bit of Spectrum Analyzer 101. This is a frequency device, so we're sweeping the frequency from left to right, rather than a probe sweeping in time from left to right. So this is showing a harmonic, or a signal, if you like, on around about 5.76 gigahertz. So that's coming out of the signal generator, and it's relatively clean, so you can see there's not too much stuff here inside. I can blow it up a bit, so you can see, you go that way. So what I'm doing is I'm widening the bandwidth, so you can see, just how clean the signal is. And these little bits of fur around here are known, if you get that too wide, that's known as phase noise. So you can see that's relatively clean. I'm pretty happy with that. As a portable field source, it's ideal. It's perfect. So starting from left, the controls are the tuning control. That moves the display left and right, much like the time ace on a Pro. This is the bandwidth control, so I can go in and have a look at all the spectrum. So that's 50 megahertz from here to here, and obviously that's quite a small slice. And this is the attenuator. So you have to be careful not to put too much signal in these things, otherwise you will blow them up. And that allows me to change the height. So that as I add more attenuation in, let's get more bandwidth in that. So you can see the signal increase. That's the reference. So that's the attenuator. Other than that, it's a very, very basic device. There's nothing too complicated about it. It's 1980s vintage, so they're very easy to drive for home use.
Just discovered is that by moving away from 10.3 gigs where he wants it to tune, by going down to 9.8, was it?
9.8.
It
goes down to
where
16
the feed
dB.
works best.
16 dB at 9.8 gigs.
It's exciting when you find this, because then you know that you've got some adjustments to do.
Well, it means that the feed inside the end of the dual band feed is actually too long. So it's actually going to be shortened by 500 megs to shift it up. And that's a lot. Yeah, well, the length of the feed in there is only 7 mil long, so 500 megs, you know, that represents quite a percentage of change.
I'll be half a mil, I would say.
Yeah. The hard part is the fact that it's right down inside.
And it's soldered on.
Trying to get in there to actually do any adjustment.
Got some work to do on that one, Doug.
Yeah, well, the problem is it's right down inside the tube.
Well, you just have to get in there.
Start again.
Easier said than done.
But it's the old story.
Actually, you know something? The way I did that, if I've got a good run in there with a soldering iron, I could probably move that pin enough to actually adjust it by the
you know, the
at
length
least a fraction of a mil.
The length of the pin is probably the less critical adjustment compared to the position of it in relation to the backshore.
Another little trick I stole from somebody else is a quick little ident system using the 817. Using it has an internal CW keyer. I just brought this out to a switch on the front panel, and while we're around this side of the dish, when you flick the switch up in CW mode, it just sends out a series of peeps or another ident signal. Very handy for peaking the dishes on receive and transmit.
Well, that concludes part one of Brisbane VHF Group's Microwave Tune-Up Day. Hope you've enjoyed the video so far, and we'll see you in part two.
Thank you.